Hey there, hello, Sindre here, associate professor in something. I do two things in my capacity as an university employee. I teach project management to students and I supervise students on writing their master thesis. And usually there seems to be a disconnect between these two, but I think actually there's a lot that students can learn from project management when it comes to writing their master thesis. There are a lot of mistakes that students tend to do, and I think many of these mistakes could have been avoided if the students were just using the techniques and methods and frameworks and tools they are learning in the project management courses they are taking. So in this video I thought I would cover one such tool, and that is the SMART framework. Now SMART, what is that? That is an acronym for specific, measurable, achievable, relevant and time-bound. And the idea here is that when you have a goal or objective, they should be SMART. Otherwise, it's going to be a lot more difficult to achieve or obtain this goal or objective. Now, just to take a step back here, a master thesis is essentially just a document, right? But the innate purpose of this document is twofold. Number one, the master thesis aim to establish some kind of research question, and then it proceeds to number two, to provide an answer to this research question. That is essentially all that the master thesis is. So a core component here of the master thesis is the research question. And the research question, that is essentially just like an objective. You're aiming to answer this question. And it's a very good idea if you can ensure that your research question is SMART, specific, measurable, achievable, relevant, and time-bound. Because if it's not, you are probably not going to get as good grade as you are hoping for. So, it's easier said than done, I believe. I think pretty much every student agrees with me that's a good idea for your research question to be SMART. And I tell my students that numerous times as they are writing their thesis, but it never seems to really be the case that they end up making a question that is SMART, specific, measurable, achievable, relevant, time-bound. So I thought here in this video I will go through the several iterations of my own master thesis, of the research question I had in my master thesis, and kind of take you through a tour here and see how I went from a very not smart research question, how it gradually, through each iteration, through each interaction with my own supervisor back in the day, it turned into something more reasonable. So, point of departure, my research question was pretty basic. It went as follows. Which model is best at forecasting volatility? So, there was no doubt that my supervisor understood exactly what they meant, because he was teaching a course, research methodology, which was mostly about econometrics. And in that course, we learned about the different econometric models that can be used to forecast volatility of your stocks. So he understood what I meant, but as he pointed out, like, this research question is not SMART, it's not specific, it's not measurable, it's not achievable, it's not relevant, it's not time-bound. So you need to fix this. So the first thing he kind of pointed out is that volatility is a property or characteristic of some sort of time series or object or entity. You cannot just ask for volatility without also making clear what it is, this object that you want to measure the volatility of. It would be kind of like me asking what is the weight or the height without specifying the thing or person I want to know the height and weight of. So the first thing I did here to kind of repair this was to add that. What exactly is it that I want to measure the volatility of? So it's not specific before I do that, at least. So my second iteration here is going to be which model is best at forecasting volatility of the Oslo Stock Exchange All Shares Index. So that was like the first thing he pointed out. But like, is this good enough? No, not at all. Is many things wrong here. But let's start with the things that are actually correct there or sufficiently good. And that is the letter R and the letter T, the relevant and time bound. I think my research question actually is kind of on point when it comes to the last two parts of the SMART framework. So is it time bound? You don't really see that from the research question, but it's kind of by default there when it comes to a master thesis. Because when you're writing a master thesis, you know that you have until a certain date in your last semester to finish the work and submit it. For my university, that would be like 15th of June in your fourth semester. So the deadline is there. We know exactly how much time you have to do this research. It's kind of incorporated here into the context, even though it's not directly specified in the research question. So it is time-bound or time-based. Is it relevant though? Relevant, I would disaggregate that into three subcomponents when it comes to writing a master thesis. In order for the research question to be relevant, the research question has to be related somehow to the discipline that you are writing your master thesis in, the study program that you are doing your studies in. And the reason for that is that if you don't, then you're not going to really qualify for getting your degree. So if you're a psychologist, then your research question has to be something based on psychology, right? And if you're an economist, then your research question has to relate to economics somehow, and so on and so forth. So is my research question related to the study program I did, which was your finance? I was like doing business economics with a specialization in finance. Quite clearly, I would say that is the case, because in finance, most of the time you're basing your decisions on the Markowitz model. In the Markowitz model, there are two components to making decisions. When it comes to like investment decisions in the stock market, is expected return and is volatility. So you need to be able to forecast both of these two inputs in order to make your decisions. So my thesis here was about trying to figure out which kind of model is best at forecasting volatility, which is an important input to decision making. So clearly it is related to finance, which is what I was studying and trying to take a degree in. So that is one out of the three subcomponents of relevant. The two other subcomponents kind of has to do with how the thesis as a whole is evaluated. Now, in my opinion, like thesis, or not in my opinion, but in order to get an A on your master thesis, the master thesis needs to be publishable. Whether or not something is publishable can be disaggregated broadly into 5 things. Utility, novelty, the correctness, if your research is well written, and so on and so forth, right? So when it comes to making the research question smart and making it relevant, I would say that two key criteria here is that your research question allows for your research to have utility, and it allows for your research to have novelty, because those two are important when it comes to making your research publishable. So is this research useful? I would say so. As established, being able to forecast volatility enables you to do decision making in finance, investment decision making. So there is utility there. Although we could argue this more broadly or more specifically, but for now that's good enough. But does this research question allow for novelty? That is not so clear based on this research question. It's a bit ambiguous. There is possibility to have novelty, but it's not clear based on this current formulation of this research question. So let us move on here. So the second iteration of my research question is as follows. Which model is best at forecasting volatility of the Oslo Stock Exchange All Shares Index? And there is issues there. So there's issues here in terms of this not being specific enough, not being measurable, and not being achievable. So let's just go through one by one here the different issues that I can point out here with this research question. The word model is quite ambiguous. It's not specific enough, because model could mean so many things. There's like an infinite amount of models you could potentially consider here. So am I going to test all of them? That is clearly not achievable. So by being vague and saying model, it kind of implies that I want to test all models, and that is not achievable within this time constraint that I had, that you need to finish by the end of the final semester of your degree. So we need to be more specific here. Now, models comes in two categories. You have parametric models and you have non-parametric models. So since I was doing empirical research, it would be relevant for me to do only parametric models, only consider parametric models. So my third iteration of the research question was, which parametric model is best at forecasting volatility of the Oslo Stock Exchange All-Share Index? But again, this is not specific enough because there are an infinite amount of potential parametric models, and you cannot possibly test all of them, so it's not achievable. So we need to be more specific than that. So when it comes to these volatility models for forecasting volatility, there are four main categories of models. You have historical volatility models, you have ARCH-type models, and ARCH is an acronym, not an acronym, but a portmanteau for autoaggressive conditional heteroscedasticity. Oh wait, no, that is an acronym. Yes, that's an acronym. No, it's not, because AR is autoaggressive. So it's a portmanteau. Yes, autoaggressive conditional heteroscedasticity model. And heteroscedasticity, of course, is just the opposite of homoscedasticity. So varying variance, right? Four main categories: historical volatility, ARCH-type models, implied volatility models, and stochastic volatility models. And these models are so fundamentally different from each other that it's difficult, to compare them because you need different methodologies. So it makes sense here to kind of narrow in on one of them, or two of them at least. So my fourth iteration of the research question that went as follows: which historical volatility and ARCH-type models is best at forecasting volatility of the Oslo Stock Exchange All-Share Index? So I narrowed in on two of these four categories of volatility models. So by now, it's getting a little bit more narrow, a little bit better. So more specific makes it more narrow and more achievable, right? But still, this isn't quite good enough because there are so many different ARCH-type models. No one knows really how many there are because it's a bit vague and ambiguous. It's kind of like asking how many countries are there in the world. There's a little bit of debate back and forth regarding that on the specifics, but it's approximately around 200, right? It's kind of the same story with ARCH-type models. If you look up the literature, you can easily find like 200 different ARCH-type models. So which ARCH models am I intending to test there? Am I trying to do all of them? That is clearly not achievable, again, given the time constraint that I need to finish by the end of the final semester. So these ARCH-type models, there are many different kinds, and you can kind of categorize them along different dimensions. You have ARCH models that are univariate and others that are multivariate. You have short-term memory ARCH models and you have long-term ARCH memory models. And you have symmetric and asymmetric models. So what am I exactly thinking of using here? So to be more specific here, I narrowed down to only look at univariate, not multivariate, but only univariate. And when it comes to memory, I focus only on short-term memory models, and I consider both asymmetric and asymmetric. But again, that is not really specific enough because there are many models within those categories. So which models specifically that I want to test? I know you're kind of running into a problem here. That is, there's a limit to how much information I can put into a single sentence, right? So my fifth iteration of the research question became a little bit something like this. Which of the proposed historical and ARCH-type models is best at forecasting volatility of the Oslo Stock Exchange All-Share Index? So proposed is vague there, but that's okay because I specified in the surrounding running text, that is before and after the research question, what exactly I meant. So what did I write? I wrote, for instance, that given the choice of excluding stochastic volatility, implied volatility models, multivariate and long memory ARCH-type models, the following historical volatility and ARCH models are considered in this thesis. So random walk, historical average, historical moving average, among the HISVOL models, or the historical volatility models. Further, the following ARCH-type variance equation models are included: autoaggressive conditional heteroscedasticity by Engel, asymmetric gauge by Engel, asymmetric power gauge by Ding et al., exponential gauge by Nelson, generalized arch by Boleslav, the GGR gauge by Glosson et al., the nonlinear power arch by Higgins and Bera, and the threshold gauge by Sakoyan, and the TS gauge by Taylor and Schwartz. So that's specifically the models I wanted to test. And now it's becoming a little bit more achievable, because a lot more specific and therefore more achievable. So by now, this is good enough. So we went kind of from version 2 here to version 5. We substituted the model with saying proposed historical arch type models. And we specify specifically which historical volatility models and arch models that I'm going to test. So a lot more specific now, a lot more achievable. But still, there are still many words here in the sentence that is too vague, not specific enough. So for instance, forecasting. Forecasting is vague. What does that mean? Forecasting can mean so many things, right? So forecasting, when it comes to time series at least, can be done in two manners. You can do it in sample, or you can do it out of sample. So what am I referring to? Because the methodology can be vastly different from these two. So because of the vagueness here, because of not being split enough, it's not clear if this is how to measure it, right? But also because of the ambiguity here of what I mean by forecasting, do I mean in sample or out of sample? It is actually not clear if the resource has any novelty, which was a subcategory here of relevant, and if this research is achievable. Because if I intend to do in-sample forecasting, then arguably there is no novelty whatsoever in this research question, or in this research I can do based on this research question. So no, I'm not going to do in-sample, or I didn't do in-sample, I did out-of-sample. But saying that I'm doing out-of-sample is not sufficient either, because out-of-sample comes in your two categories. You have the ex-post or pseudo out-of-sample forecasting, and you have the ex-ante out-of-sample forecasting. An ex-ante out-of-sample forecasting, it's not possible to do given the time constraint, because then you need to, from you start doing the research, you make your models, and then you need to wait until new data comes in. And you don't have time to do that when you need to finish by the end of your final semester. So if I intended to do your ex-ante out-of-sample, it wouldn't be possible. It wouldn't be achievable. And the light's turned off here. I'm sitting too still. Hi. There, lights are back. Enlightened. So my train of thought there, yeah. So the sixth iteration of my research question then becomes as follows. Which of the proposed historical and archetype models is best at ex-post pseudo out-of-sample forecasting across different forecast horizons? So one thing I also forget to mention about the vagueness of forecasting is that you need to know what kind of forecasting you do. You in-sample, out-of-sample, and if out-sample, is it ex-ante or ex-post? You also need to know the horizon that you are trying to do. Are you trying to forecast the immediate next time period? Or are you dynamically trying to forecast a time period beyond the immediate next time period? So which one do you mean? They say across different forecast horizons. I didn't feel it linguistically appropriate to put the exact information inside the research question, so that's just specified in the surrounding text. But I think it was 1 time period ahead, 5 time periods ahead, and 10 time periods ahead. Or maybe it was 1 to 5. Either it was 1 to 5 or 1, 5, 10. I don't remember exactly. But it's important here to kind of specify what you mean, because a static 1 step ahead forecast is very different from a dynamic several step ahead forecast. So you kind of need to specify that also somehow. This is not in the research question, but I kind of put it in the surrounding running text, so that's also good enough, I suppose. But is this research question now smart, specific, measurable, achievable, relevant, and time-bound? Not really. There's still vagueness here. For instance, what exactly do I mean by volatility? Volatility could mean so many things. Now, the problem with volatility is that volatility is not an observable variable, it's an innate variable, meaning that before I can start forecasting like the unknown future values of forecasting, I need to first somehow estimate what the current value and the past values of volatility is. And there are many different proxies and methods you could use. And some proxies and methods are better than others, and some are more data demanding than others. So, because I don't specify what I mean by volatility here, we're gonna get the problem here that my research question is not specific, because I don't specify what I mean by volatility, and consequently, I may or may not have any novelty. If I use the simplest, most common proxies of volatility, then I'm not gonna have much novelty because that's been done before. But if I'm intending here to do some more advanced methods and proxies, then that might not be achievable because it might require data that I may or may not have. So I need to be more specific here about what I mean in order to turn this more specific, to clarify if this is achievable, to clarify if this is relevant to the undercategory here of having novelty, and also to kind of make this measurable. So I'm not going to go through all the different proxies that exist for that, but I use something called like a realized volatility, which is one of the more fancy proxies. So novelty is kind of more guaranteed then, and also data availability also need to be considered there. So the 7th iteration of my research question then became as follows. Which of the proposed historical and archetype models is best at ex-post pseudo out-of-sample forecasting across different forecast horizons, or forecasting the 1-minute realized volatility of the Oslo Stock Exchange All Shares Index? So the 1-minute realized volatility. So what the realized volatility proxy kind of does, it looks at, if you look at if you want the volatility of daily frequency, it would take intraday data, let's say the return for each hour to hour, square that and sum it up and kind of scale it so it becomes for a 20-hour cycle rather than just the hours that the stock exchange is open. So you kind of need to specify in there how frequent is or what is your intraday frequency. So in this case, I used 1 minute. So now it's more specific. Now it's more it's measurable at least. It's more relevant now. Is it achievable? That is kind of not possible to determine just based here on the research question, but this kind of begs the question, does this data exist? And we'll have to go out and check that when I'm writing my research proposal. But good enough for now, right? But is the whole research question now sufficiently good? No, it is not, because there's another vague word here, and that is best. What on earth do I mean by best? Like, best could mean anything. Like, what is the best boyfriend ever? Like, what is that? It can be anything. It depends on how you measure it. Like, what is the best pet ever? Who has the best cat in the world? You need to clarify what you mean by best, especially if you're gonna have like a competition, right? So, when it comes to kind of this continuous real value time series, such as your volatility, they are kind of two, or you kind of measure that with what's called loss functions. But loss functions comes in two major types: economic loss function and statistical loss function. So what do I mean by best? I mean like best in terms of having the highest forecast accuracy, in terms of having the lowest loss function value. That's what I specifically mean. But that's not good enough either, because there are different loss functions. Within statistical loss functions, you have loss functions that are asymmetric and loss functions that are symmetric. You have linear, you have non-linear, and so on and so forth. So what do I mean specifically here? So you kind of need to specify that, which loss functions specifically I'm going to use. And again, it's difficult to put that inside of the research questions. I put that in surrounding text. So my eighth iteration of the research question then became as follows. Which of the proposed historical and archetype models can provide the highest ex-post pseudo out-of-sample forecast accuracy across different forecast horizons in terms of a representative selection of robust statistical loss functions for the 1-minute realized volatility of the Oslo Stock Exchange All Shares Index? So then in the surrounding text, I would specify something along the lines that I use 6 different statistical loss functions that were based on patents, 2011's family of robust homogeneous loss functions. The loss functions were chosen to cover a wide spectrum of different potential preferences of the end user, so linear, nonlinear, symmetric, and asymmetric functions. And then I would give like the exact equations for each of these 6 different loss functions. So by now, I would say that the research question has become quite specific and consequently quite measurable, quite achievable, and quite relevant and time-bound. But there are additional issues here, so you will never be done with this. At some point, you just have to stop and say, okay, this is good enough. But some issues that I could mention here. Not all issues need to be addressed by the research question. Sometimes you do address it when you write your methodology or when you have your data section. So for instance, it says here that I'm going to use data from the All Shares Index in Norway, in Oslo Stock Exchange, but which time period and how long is that time period? Yeah, sure, I could say that, I'm using data stretching from 2005 to 2015. I could have said that specifically in there. I chose not to. I think the reason was because I didn't know exactly how far the database was stretching, and I hadn't gone there and downloaded the data yet. I checked that the data existed, that I could download that it was available to me, but I didn't actually see how far back it went. So I could have specified that in the research question that I'm looking at this particular sample of period. But I ended up putting that in the data section instead, so that's also okay. Other methodological issues here would be that, for instance, I ask for the highest forecast accuracy in terms of the specified loss functions. But that's a little bit vague also, because what does that mean? Do you just just take the lowest value, as it kind of implies here? Or am I using some kind of hypothesis test to make sure that the two values are significantly different from each other? So that could have been specified in the research question, that looking at which model is significantly best using a specific hypothesis test, but I put that inside of the methodology instead. Another issue not mentioned here is that if you use high frequency data, especially like 1 minute, which is quite high frequency in this context at least, that's not high frequency of course when it comes to high frequency trading, but when you use 1 minute frequency, you have an issue here that your data is going to suffer what we call the microstructure problems. You could have artificial volatility created by the bid-ask bouncing. So if someone is trying to initiate a sale or a buy but does not succeed, the price will bounce from the bid price to the ask price. So you get you kind of get volatility without there actually being any trades. So if there are no trades, there should be no volatility, but still you see this bid-ask bouncing. So that is an issue by having so high frequency data. So how do I address that? Well, I use a cubic smoothing B-spline. But again, I didn't specify that in the research question. I put that instead inside of the methodology. So just to wrap things up here, when it comes to writing a master thesis, you need to ensure that your research question is smart, specific, measurable, achievable, relevant, and time-bound. Because if you don't do that, then your thesis is going to suffer. It's going to be so much more difficult to get a good grade. Because the master thesis inherently is about establishing a research question and then proceeding to answering that research question. And no matter how good your answer is, it doesn't matter how good your answer is if the research question is bad. So if you chose a research question that is not relevant, right? It's not related to your discipline, and you're gonna fail, right? You're not gonna get a passing grade at all. And if you have a research question that does not allow for having novelty or utility, then you might pass, but I wouldn't expect to get much better than a C at best on your thesis. So very important to make sure that your research question is smart. And making sure that your research question is smart is easier said than done. I don't think many people erroneously believe that their research question is specific, but in reality it isn't. So my initial proposition, I thought that was good when I started out, but when to my supervisor, I came to realize, no, this is not specific, measurable, achievable, relevant, and time-bound at all. It's not smart. So it is very cumbersome and difficult. Like, it's gonna be a real challenge here to make sure that it is smart. So it is something you need to carefully think about. But yeah, that's gonna be it for me. Good luck when you are doing your own master thesis. Hope this was helpful. And I am going to go and give an actual lecture in project management now.